Welcome to Brain Vision.
Hi everybody, so we're doing problem 15 of chapter 21, Introduction to Modern Astrophysics. So number A of this problem is asking us if the dust gain orbiting the sun absorbs 100% of the energy that strikes it, so 100%. So it wants to know what is the luminosity of the grain, okay? So the brightness of the sun is measured by the dust grain, which is given by B equals luminosity of the sun, 4 pi r squared, and r is the dust grain. And so the rate energy absorption, and that is going to be dE dt equals B of omega g. And omega g is a cross-section area of the dust grain. Okay, so we're going to plug this B into here. So we have dE of the energy absorption. Luminosity of the sun, 4 pi r, which is dust grain, omega g. Okay, so here is the dust grain radiates all the energy falling on it, and the luminosity is equal to the rate energy absorption. So luminosity is actually equal to that. So that is your answer right there for A. Now B is, what is B asking us? B is asking us, show that the rate at the momentum is lost is given by blank. That's what it shows us. Okay, so here, the orbital angular momentum of the dust grain is given by L equals mvr. And here the m is the mass and the v is the orbital velocity. So we can take the derivative here of the dt. And when we do that, of d dt of mvr, we end up with vr dm dt. And as the mass is lost to the ejection, this actually, and we have here, so this actually becomes negative. So let me just rewrite this here. Vr dm of dt. Okay, mass of lambda. And m lambda is the mass of the photon, by the way. It's just the mass of the photon. And then we can do mass of the photon here, which is energy of the photon times the speed of light. And if we take the derivative of here of dt, we end up with d dt of energy of lambda times speed of light, 1 over the speed of light times energy of vt. Okay, and we already solved for dE over here, so it's right here, and we're just gonna plug this bad boy in. So scroll down, maybe write this here. So we have dm of the photon dt 1 c squared of luminosity of the sun, 4 pi r squared, which is the photon, and g cross section. Okay, so now we can insert this whole thing into, let me scroll back up, into that. So let me just scroll down a little bit. Okay, so dl dt equals negative vr 1 c squared, okay, times luminosity 4 pi r squared here. Now what you can do is you can pretty much just c squared. Okay. Now we're just going to double check, make sure everything's okay. Give the R, M, and M. Okay. So now, oh, my little guys look kind of really bad here. There we go. Okay, so now we can multiply and divide the right-hand side of the above equation with M. So we're going to multiply and divide here. Because what we want is actually what we can do is divide by M. And because what we want here is, so here what we really want. So we want M at the bottom. So we can actually divide by M. So we have and then we use expression of L for MB. So let's see. So multiply and divide by M. So dl dt, we end up with MVR of luminosity of MC squared. And then we also have omega G over 4 pi r squared. Okay. And now what we can do is actually dl of dt. And we are just going to make this into negative luminosity. So that's what that is. Here we already have that before. Luminosity of MC squared. Okay. And that is your answer. Okay. Thank you guys.